A greenhouse provides the warm environment plants need to germinate and grow. The greenhouse heats up during the day by the warmth of the sun. After the sun sets, the temperature quickly drops. This is most problematic in the winter months, when the days are short and the nights are extremely cold. Supplemental heating methods are then needed to warm the greenhouse.
Our project focuses on the greenhouse at the local Food Hub's educational farm in Scottsville, Virginia.
Bum, 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 bum.
Meet Steve. Steve is the farm manager of the Food Hub's farm. Steve wants to reduce heating costs in the greenhouse. Because he's already busy with a number of other projects, Steve wants to do this in the simplest way possible.
Currently, propane is used to fuel 2 heaters in the local Food Hub's greenhouse at the educational farm in Scottsville. Instead of concentrating the heat sources to the plants, the propane heaters pump heat into the entire structure. This system, powered by propane that costs approximately $4,000 a year, is expensive and inefficient. Instead of heating the plants directly, the warm air rises to the top of the greenhouse and leaves the plants below subject to colder air.
Rather than heating the entire greenhouse, attention can be placed on heating the plant's soil, because the soil temperature is more critical to a plant than its leaf temperature. Here are a few suggestions on how to accomplish this goal. A heat source positioned directly beneath the soil would be the most effective way of providing warmth to the roots. This can easily be accomplished by placing an electric blanket underneath the plants. An electric blanket would keep the soil warm while not wasting energy warming parts of the greenhouse that do not need heat. Electric blankets are inexpensive, and the electricity costs would be cheaper than the equivalent cost of heating the greenhouse with propane.
Materials that retain heat well during the day can provide a heat source throughout the chilly night. Water has a high specific heat, making it an efficient heat sink. Filling barrels with water and placing them throughout the greenhouse would be cheap and easy. Another simple method is to line the plant soil beds with plastic bags full of water. This would be a sort of water bed retaining heat where plants need it the most, in the soil. A more advanced method, solar hydronics, pumps warm water through a series of pipes beneath the soil. Hydronics maintains a steady temperature even throughout the night.
Adding a thermal blanket to the roof of the greenhouse and additional layers of insulation to the walls can retain heat. Increasing insulation in areas that do not receive much solar exposure, such as the knee wall in the north side of the greenhouse, will help to contain heat inside the building without blocking sunlight.
A greenhouse's access to sunlight is critical to its heat retention. A thick batch of tall pine trees sits just behind the Food Hub greenhouse to the east. These trees cast a wide shadow over the greenhouse from dawn until 9 a.m., cooling it significantly. Removing a small portion of these trees would greatly increase the solar gain of the greenhouse in the morning hours. Losing these trees would not affect the environmental stability, but rather restore the land to its state before the trees were planted. The lumber would then be used for other projects on the farm.
The cheapest solutions are the water barrels, beds, and electric blankets, while the hydronics, thermal blanket, and insulation require greater resources and labor. Only the hydronics, thermal blanket, and insulation require major effort to implement. The other solutions are easy to install. Naturally, the most effective solutions are also the most expensive. However, all methods will make a tangible difference in heating the greenhouse. Our proposed solutions will help the local Food Hub heat their greenhouse without depending entirely on propane. In the broader context of greenhouse management, These and other technologies can address heating efficiency concerns across varying scales of greenhouses.